All right, good morning, good afternoon, everyone. Hi, myself and Marco, we're going to run through the updates for the concept modeling and optimization tools in version 2025, and just also recap a little bit of what's happened in 2024.1. We didn't do a GTA last time, so we're going to add some content in there as well. So just going into a little bit more detail, a lot of today's focus is going to be on the skeleton modeling and the automation of the skeleton modeling. So creating reduced order models in a more efficient timeline. And the tools we've added, so categorize, I'll walk through that. Line extract and interpretation. This is the first instance whereby we've got a midline extraction tool now. And we've made many updates to our section creation and line absorb capabilities, not just in quality, but also performance as well. So we're quicker and we're substantially better at creating these sections now, which reduces a whole bunch of manual user cleanup further downstream. Marco will then talk about the new order offset plus the major release for the section manager. So this is the first instance whereby we are replacing a hyperbeam. I think you'll like what you'll see. It's all sketch based, it's extremely powerful, and the usability is really fantastic. I'll then jump back and talk a little bit more about some of the updates for design space. Okay, I wanted to start by just giving a really quick recap of all of the concept modeling and optimization capabilities available today. So related to design space, you have the global body in white or subsystem design space setup, local for doing structural adhesives, structural baffles, structural inserts. It can also be used for castings. So this is where you've got a design space that is very localized. You're kind of space constrained. We've seen a lot of good uptake with the adhesive and spot weld optimization capabilities as well. So a lot of the new EV and OEMs out there are actually leveraging this now and seeing very good results. Two of the newer capabilities during the later 2023 and 24 releases, exoskeleton and also order box. So exoskeleton, typically for MVH, further downstream, allows you to run topology very quickly to find out where a structure needs to be reinforced. Okay, so don't spend time with the voxel design space. Go to these 1Ds, and you'll be able to run the optimization in a matter of minutes to give you conceptual guidance as to where to stiffen the structure. And then the last one that I wanted to mention here was order box. We can take any individual part or subsystem. We can throw a voxel design space around that part or subsystem. We honor all the attachment points, and then you can run, basically you've got a run ready topology optimization in a matter of minutes. So it's extremely powerful. And then a couple of tools on the right hand side for interpretation and setup, which have been there for a while. So a lot of today's discussion is going to be focused on the creation process for reduced order modeling, so skeleton. So bottom left hand side, we've made substantial improvements there. We've got all the interpretation tools to go from an optimization of a 1D back to a 2D mesh or surface. Sketcher is such an integral key component or capability within this whole workflow, not just for reduced order modeling, but any conceptual, any design change. It's really a fantastic feature within HyperMesh. Section library, and then geometry reconstruction as well, which plays a major factor into this discussion today. So let's talk about what we're doing for the skeleton automation in 2025. So there's three main updates: organize, extracting the midline, and then improving and extracting the sections directly. Why do you want to do all this to start off with? Essentially, it's reducing the model runtimes. So maybe for model, you don't see much benefit, but certainly for crash and optimization, this is where you get the real bang for the buck. So you can see the timelines at the bottom there are substantially different. So the investment you put into creating these models pays dividends when it comes to crash especially, and optimization. So that's the real incentive for doing this: more design change, getting those results quicker, making design decisions to fast track the development of the model that you're working on. Obviously, we can take a number of different inputs. So it could be topology, CAD, and or even a more detailed donor model. There's a whole bunch of ancillaries, so things like the powertrain and everything else that need to be kind of pumped into the model depending on the fidelity that you're interested in. Today is mostly going to be focused on the body in white. There'll be separate sessions in the future and through our UK team to talk about the crash setup as well, and really making sure you got that right fidelity depending on the load case and an application. So really we have a complete suite of tools to really go from the left-hand side to the right-hand side in a pretty short amount of time now. And what I'm talking about today is really the tools available to you out of the box in Core in 2025. Using the C123 solution and the Core solution, going back 4 years, you can see that it was taking many weeks to generate an average reduced order model. But now you can see we're down to around half a day, and I think in the future you're going to see that time obviously drop even further. So you can see the pretty substantial drop off in the interactive model build times here. So how have we done that? Well, we've added a lot of capabilities in Core. And so just taking this example, going from donor, the first capability we've added is categorize. So we can now take a body and white model and we organize the model into sections, which is really the key component to the next step, which I'll talk about in just a second. We organize the panels, the castings, the hard points, and the glazings. Now, all of this capability was available in the C123 scripts. We've brought that into Core, and as a result, the robustness and also the performance is improved pretty significantly, which is obviously a step in the right direction. So once you've got the output from that, you can then run on to the second step, which is really extracting the midline. Okay, so that's in 2025. This is also in 2025. So we can go from the sections, extract the midline, and then from that, we can then reverse engineer the sections based off that skeleton section set, and then create the reduced order model significantly quicker. And I'll go through a lot more details in just a second. So here is the public domain model. And just, I wanted to show this just to show you some timings. Now the timings here are just raw compute processing time. None of this is interactive time, okay? So it takes around 4 minutes to go from this body and white and extract the sets for the skeleton panels, castings, glazings, etc. The line extract is pretty quick. There are two paths you can take from that. You can take the raw output, which my recommendation would be to actually probably clean that up before you can move forward, and I'll show you a demo of how you do that. But if you take that raw output, which takes around less than a minute, I would say, it takes around 17 minutes to then process. But there's a lot of noise and additional sections that are going to be generated there that may not be beneficial. So my recommended step is to do the line interpretation, which is a manual step. I'd say probably in 5-10 minutes you can get a relatively decent cleaned up model, and then run the absorb function here to create the 1D mesh and the sections all in one go. So you can see here in less than probably, let's say 30 minutes to an hour, you can get something relatively decent. Then obviously you can add on the panels, the castings and everything else and splice those back into the model to add that level of fidelity and detail that is needed. Okay, so there are three contexts that were added in 2025. So categorize, extract line, and then Marco is going to talk about the order offset. And just walking you through that process, and I'll show you a demo of this in just a second. All of the inputs here, so you've got general, the hard points are optional, and we are organizing the glazings, the castings, and the panels. I'm not going to go into each and every single one of these options. It's all detailed in the documentation. But long story short, you end up getting, this is the output with a number of sets. From that, you can then take that skeleton set or section set into the line extract tool. Again, there's a whole bunch of options. I'm going to talk about those in a little bit more detail in just a second, and extract the midline. You can then manually clean up. I'm going to show you a demo of how I would tackle or approach this. And then you can then submit to absorb, which will take that line data. It will do a spatial scan around the structure. And then at the control points, it will then create the sections in the 1D mesh and create that 1D structure for you. And then just one minor update here is that we added additional control for the members and the component/part organization as well. So whether you wanted it all in one or split up, you now have full control over how that is created. So that's everything on the skeleton side of things. I just wanted, or the categorize, sorry. I wanted to now talk about briefly just the line extract before I jump into a demo. And the line extract tool is the first release. I'd expect many updates and improvements to come in releases to come. But the capability now allows you to basically take a detailed model and extract the midline, but also more importantly, or as important, is creating a midline from a topology result. Okay, so you can go from a 3D topology result or even 2D, extract the midline, and then whether that's a 1D representation or you're creating ribs or whatever it might be, it's a pretty powerful interpretation tool. There are a couple of options. So we automatically fill and patch the holes, in this case in the upper left-hand side. Otherwise, the algorithm will actually bleed out. So you'll need to make sure it's vaguely watertight. The resolution is obviously the resolution of the level of detail of the line extract. And then there's two other options here. So branch length limit on the top right here, you can see that we actually consolidate the number of legs if that parameter is set. And then the collapse threshold is really for jointed locations to make sure that anything within a certain tolerance is then snapped to one control point or one junction. So the line extract, not only can it be used for taking a 3D model and extracting the midline, it can also be used as a tool to interpret 2D topology. And this is just one example here whereby Rajesh was wanting to extract a midline from this to actually create a ribbed structure for a plastic injection molded part. And you can see that we can take this 2D topology, extract the lines, and then you can just do a basic extrusion and splice that back into the base plane, obviously with a little bit of cleanup. But you can see now that, yeah, we're able to extract the midlines there. And then the other example is in aerospace type structures, again, 2D topology. Here you might want to create some ribs, spars, whatever it might be. You could use that as guidance for that interpretation. Okay, so that's the slides. I'm going to jump out now and just show you a quick demo of the workflows here. So under skeleton now, we've got categorize, and this is the list of parameters. Honestly, I would probably leave this by default, unless there's something very specific in your model that it's not finding or not allocating or categorizing correctly. So I would hope that, yeah, there's not an awful lot of need to poke around with this, but we've exposed it, and we can tweak it as we move forward. So the inputs, components, elements, parts, you make your full selection. If I have hardpoint locations, then obviously I could set those if they were important. I'm not for this. Now this will take around 10 minutes to execute, so I'm not going to spend time waiting for that just now. So this is the raw output here. And you can see that if I go to review now, I have my glazing flanges, I've got my glazings, I've got my castings, I've got my skeleton set here, which is the one that I care about to go on to the next step. And then I have my panel organization as well. Okay, so this has been designed with many models, probably at least 20, if not 30 different body and white. So I'd say the logic is extremely robust now. But yeah, if you do run this and it's not organizing as you'd expect, do let me know. So from that, if I now go to isolate this set here, okay, so this is the one I'm interested in, to go to extract line. Now these were the parameters I was just talking about with the branch length limit and the collapse threshold. I'm going to go now and just create the now I want to show my symmetry plane to start off with. There you go. Right, so default resolution is at 20. I've already created a symmetry plane. I am going to use that because I want to create it in half symmetry to start off with. So I only do half the cleanup and half the work, and then I'll just reflect it later on. So now when I click go, this will probably take less than a minute. But my approach here, I mean, you could run this without symmetry, and I'll show you a different strategy as to how that can be interpreted using line absorb. So there's a couple of different ways you can do this. So that's now complete. So I don't know, maybe that was 20 seconds. So under components, we scroll down to the bottom. Just want to show you that we actually patch the model completely. Okay, we don't care about the quality. It's just a rigid body mesh to patch all the gaps. And the one that I do care about is the skeleton set here. So now if I review, this is the raw output. Okay, so this gives you conceptual guidance as to how this line should or the midline construction should be interpreted. Clearly, there are some issues around some of these local junctions. You've got to be careful about what you're submitting, because here you've got this these additional parts or elements here. Clearly, that's skewing the mid-plane symmetry here. So you need to obviously interpret from this. Now, the overall goal is to make this a one-click solution. That is still the target, and we are extremely close to that. So expect to see further updates in the coming releases. So from this, you might be asking, well, how do I interpret that? There are a couple of different ways. I'm just going to make sure that my geometry is created. Okay, so I'm going to go to create, and I'm just going to create that as blue for now. I'm just going to go to isolate that. Now you need to make sure, obviously, that this is going to be in relation to the structure. You can't have these midlines kind of poking out through the structure, otherwise, well, that's not where the load path is going. So you do need to be relatively careful with what you're doing here. But just to show you at a high level, without taking too much time, under topology lines, if I was to do this, I'd probably start by just interpreting some midlines. Let me just go to this junction point here. Let me create. But you can see here that the organization now is within this skeleton set. Ideally, I didn't want to do that, but I won't take any more time. So under the polylines now, I can still go through, and I'd probably recommend that you create junctions at the key points. And you can see now that I can go through and very quickly, let's just go here and actually clean up this interpretation, which is fine. Now you might be asking, well, how do I do the midline here? So what I'm going to do here is actually just go back to my set. I'm going to turn on my complete skeleton, and this time I'm going to go to sketch. So this is why I think that the sketch is incredibly important. So if I go to intersect, I'm going to pick the direction. I know the direction needs to be 0, 1, 0. Okay, and I know that this is typically going to be offset, so put that back to 0. Now that is the true midline, and if I go to intersect, so that's the junction I'm working with right now, the section plane. So I know that I need to have a point along this section to do that interpretation. So under point now, I'm going to click here because I know that this is a bunch of noise here that I don't want to include in my my interpretation. Let's just say I want a point here. Maybe that was a misclick here. So I'm just doing this very quickly in the interest of time. But you can see that I can build out this this profile definition. I won't do the rest now. Very, very quickly. So I could need to do this at the front, obviously, and right the way around, but I won't do that now. So now when I back out of that, go to components, and let me just isolate my set again. And this time I want to isolate. That's fine, and then go to components. All right, so now I've got my midline extracted points here. So now I would go back to topology again, polyline, and then wherever the snap point was here, I could just now go and leverage that directly. I'll probably need an additional control point in that, but you get to see how leveraging the sketcher and the intersect, we can actually create a much more clean and detailed representation. Okay, so this would probably, I don't know, take 10 minutes to clean up, maybe a little bit longer, but yeah, using the sketch and the polyline with this mid-plane extraction, that's one approach. So the other approach is to extract the skeleton in full. So no symmetry, and rather than me run that again, I'm going to just load in a model. Okay, so let me just go back to here, and I'm going to just delete that. Okay, so this is the raw output from the midline without any symmetry. Okay, so the other approach that you could do to approximate this and clean it up a little bit is go to absorb, and then if you turn off right now the realization. So I'm going to show you with and without. This is the key bit to really fast track these model builds. So right now I'm going to leave the control point locations on, and I'm going to say, right, create members, but I'm going to reduce my control points down to 2, such that it will straighten out some of the curvature and filter out some of the noise. I probably shouldn't do this on the whole thing, but I will. So if I go to now and click on create, you can see now that returns something pretty quickly. There are some funny issues going on here, but that's a function of the extract line. But you can see for the most part, this is relatively clean, and you can begin to see that these things are getting straightened due to the control points. Now, with these sort of issues, for the offset here, I can go to pick, and I can see that distance is around 100, let's say 20. If I go to equivalence now, and I'm going to ramp this up to, let's just say 150, put that to 150. And now I'm just going to pick the members, say find, merge, and it will actually, oh, yeah, okay. So what I did here is I had the option here to collapse the legs. I need to disable that. So let me go back here, turn that off, find, merge. And you can see now that the control point is actually snapped. If I needed to move that, I could go back and actually move the joint leg into the position, the exact precise position that I wanted to. But you can see we've got all of these snaps and filters now to actually make sure the joint locations are good and there's no offset. So this was another location at the B pillar upper here, where there was obviously an offset, and we've consolidated that down into a pretty nice jointed junction. So with all that being said, let me just jump back to I just want to go through and just delete all this again, and I'm going to create one line and just show you the absorb. So for those of you that aren't familiar, let me just go and create a high fidelity line here. That's fine. This is the interpretation I want. Now if I go to components, sorry, sets, I'm going to turn on the skeleton again. Show. Okay, so this is what I'm working with. And I want to go back to the lines and just review them. And now if I go to skeleton, absorb. Now before, when I was using this, I turned everything off. Okay, I'm going to turn everything back on. So we create sketches now. I'm going to talk about what this cleanup does in just a second. And we create the 1D mesh, we auto weld it, and a whole bunch of other stuff. And it's extremely powerful. So now if I go click that good line, and now click go, that will create the 1D mesh, the beam sections. It'll create the sketches that are fully editable. And you can see now we've got a pretty nice output. Now, this last section obviously captured the jointed junctions, so we can just exclude that. But you can see here that for the rest of them, it's all turned out pretty nice. And yeah, obviously you can do all of that in one go to the whole model, and you end up getting the 1D structure in probably about 20 minutes, I'd say it would take on this. Okay, so that's the demo for the categorize and the line extract. Next, I want to move on to the section cleanup. Okay, now there are three contexts that we've updated, joint box, member, and absorb. And all three of those have this new section cleanup option, which honestly, it saves hours, tens of hours probably. So in 2024, if you used skeleton, we would go from joint A to joint B. And depending on the sketch plane, the cut plane, the size is default 300 by 300. We would over capture in cases, which is expected. You could play around with these individual cut planes and things, but yeah, it would still probably not be ideal because you need varying cut sizes per plane and things like that. Anyway, and you can see the raw output. So you can see the control points are not in the location due to the over capture of these areas up here. And you end up getting basically this on the right hand side, which is not in the correct location, plus you've got the overspill and the 1D elements on bits that aren't needed, or the section. In 2025, even with the cut plane overspilling into an area that you don't want, depending on how it's, depending on the composition, as long as 50% of it or more is on the bit that you want, then we will capture the correct section profile, we will dismiss and ignore the overcapture, and we will create the control point in the correct location. Therefore, you get what you see on the right-hand side. So this in itself saves a huge amount of time. So this was the behavior as we were developing this. Even with the filtering out, you can see that we weren't capturing the control point locations correctly, even though we had perfect sketches and profiles. So we updated the control point as well. As a result of that, though, this step does take marginally longer interactively. So you're paying a penalty to get a much better quality output, which will save you a huge amount of time further downstream. So it does take maybe a handful of seconds more to generate the interactive previews and things like that. because we're trying to calculate these new centroids and filter out some other noise. So we go from top left to bottom right now in one go. So let me, before I do that, I just wanted to show you just this slide here. So this was a full model with the raw output from the line extract. It wasn't cleaned up, so there's an awful lot of noise in this model already. And this was really just a dumb academic performance test. And you could see that from this, without the section cleanup, it was taking around 21 minutes. With the section cleanup on, it's taking 10 minutes. Obviously, it's doing way less now because you can see these areas around here and here, there's way less to do because we're filtering out. There's another area around here. You can see we're doubling up. There's doubling up around here. So all that overcapture is a huge time penalty, time sink, not just from the processing time, but also from the manual interaction cleanup time further downstream. So each and every one of these sections need to be validated properly. And I think this is a massive step forward to improve that. So I'm just going to jump to the demo, then I'll hand over to Marco for the next topic. So let me just read in this model here. And once that's read in, I've already got my members and everything set up at the joint locations at the back here. So if I go to member now, and by default, I'm going to turn this to no cleanup, and the control points is 3. That's fine. If I go to A to B, this is the preview that's getting generated now, and you can see exactly the output. Okay, so this is 2024 behavior. If I click go now, we get the 1D mesh along that profile, plus the somewhat noisy sections. And actually, the creation process is slower because obviously it's trying to create twice the amount it should be. So that's the output. If I just undo all this, and now go back to default, which is default actually, and you can play around again. You probably don't need to play around with these parameters. Click joint 1, joint 2. This is going to be the preview, and this is going to take a little bit longer because we're doing the filtering interactively now with the centroid computation. You can now see that we have filtered out all the additional noise without changing the profile of the cut planes. And now when I click go, this is actually quicker now because it's processing less. And you can see now we've got a very clean output for that profile of that rear fender.
Hi everyone, this is Marco, and today I would like to talk about a couple of new tools that we added. I hope you will like. The first one is Section Manager. As the name suggests, is made to handle sections, and in the 2025 release, it will persist together with HyperBeam, but in the future we are planning to replace HyperBeam in favor of Section Manager. First, why we design Section Manager, why we need it. So as Stuart presented in the reduced order model workflows, we heavily need to create, edit the sections, beam sections. And this is true for both early design stages where you need to create a new topology for the section, so the shape, and also for detailed design stages where you have to fine-tune the parameters, the thicknesses, and probably adding some small changes to the shape of the section. So for that, as an example here, I have a typical use case where on the left you have the original section before any design change, and the typical changes that user may want to do. So first of all, you of course can change some lines, so profile a little bit better some of the parts, or adding beads or corners. So all of this, it's possible, especially if you have a good way of managing that lines. And we thought that the Sketcher is the best technology that we can provide for that. So here you have on the left HyperBeam and the new Section Manager as side by side for comparison. Of course, there are differences, especially with the graphics. We are using the Sketcher as the main provider of the graphics, but also the benefit of the Sketcher is in the usage of all the tools that are inside the Sketcher for creating, editing the topology of the section, as well as bringing the ability of parameterize the section. So all the variables that can be used and the expression to fully parameterize your sketch will be used to compute the sections. Everything is tied together. And in the future, we are also planning to leveraging this for optimization studies embedded with OptiStruct. So again, a list of benefits, maybe some of them already have said, but let me reiterate that Section Manager is an evolution of HyperBeam, bringing in a new intuitive and modern interface with the very well-known Sketch module. In fact, users from HyperMesh and Inspire as well that are using or are familiar with the Sketcher can easily jump into Section Manager. I already said regarding the tools of the Sketch that allowed you to easily create and edit the section. The 3D graphics that it's a good example of how you can correlate the section with the 3D model, HyperMesh model that you are working with. And we will see in a while directly with a demo all the other feature, and especially we anytime we read the sketch lines, we group them together to, for example, for assigning the thickness to the line. So let me go to HyperWorks so I can show a demo on Section Manager. Here I have a model of a car with some beams and a relative section assigned to it. And for example, I would like to open it in a Section Manager. So very similar, if not exactly as we all are used to do in HyperBeam. From the Beam section browser, we can right-click on the section we're interested in and go inside Section Manager. So here you can see that the sketch module has been triggered, and now we have the section that directly reference into the model, of course. And on top of the sketch graphics, we added these two dots. These two dots are the shear center and centroid of the section, like in HyperBeam. And here on the right side, we also have a new browser, the Section Manager browser, where you can turn on off these dots. On the other parts of the Section Manager are contained in tabs. So this tab, for example, is for the properties. So the engine that in this case is the thin wall engine that is triggered anytime that we do any change that in the sketch that we commit, and calculate dynamically all the section properties. And this list is one-to-one matching to what you are used to have in HyperBeam. So it's I don't think we need to go through all of this because it's already known. While on this other side, we have for this specific section shell parts. So shell parts, it's as I said, we are grouping the lines inside the sketch into groups. So it will be easier for the users to change, for example, in this case, the thickness of these lines. And I can also show that if I pick, for example, this group, these lines, and if I change here the thickness, you probably didn't notice, but the engine has been triggered, and we have all the properties that have been updated, but at the same time, also the position of the shear center and centroid moved a little bit. So from here, you can easily handle the the groups. And what if you don't like the way automatically we group all these lines together? Well, you have the possibility, for example, to pick any of these. Here you have a column with the counting of lines. So here you have 5 lines, sketch lines. And if I want, because maybe I would like to assign a different thickness to some of them, I can, with this tool here, split them in separate components. If I change my mind anytime, here we have the reverse. So we can merge part together. I can pick any line and merge together, but we have some filtering, so you cannot pick any line as you want. That lines should be continuous. So that means that they have to be attached each other. That's because the engine will need that kind of input. Maybe in the future we will also update this. But for now, this is the logic behind the grouping. As this more or less this section, it's already been, let's say, seen all these aspects. I also have, as I see I have time, I also prepared a very basic section here, just for the scope of showing additional features we have in the section manager. In this case, this section is, if you see in the BIM section browser, it's a different type. It has a different config. In fact, the engine is different, and in this case, this engine allowed us to use and compute both solid and lines in together. So this is why right now on the tabs I have an additional tab, the solid parts. So in this case, in the solid part, I have these lines that form a solid, okay? And we have additional columns. I will explain in a while what they are. And we will see that in the shell part instead, we have the other 2 lines. If I want I can also convert in case, well, my section is not solid, but I would like to have here just thin parts. I can convert this with this button to be shells. In this case, you will see that now the group has been moved in the shell part, and now I can treat as other shell parts lines and assign thicknesses. Of course, I can, with the same button, I can move from the shells to solid, so it's bidirectional. Now, just to show you also the interaction between the sketch and the engine, I will draw here another rectangle, okay? So you will see that automatically a new solid part has been created, okay? This is also 4 lines. In fact, it's a rectangular inside. And now you will see why we have that column. So here automatically recognize that we have the rectangular inside this other one. And so is referencing this inside this part. And here you can see the link between the two. In addition to that, anytime we recognize this path, we assign the interior of this as a whole. That means then now the properties will be computed meshing just the exterior part, but this part inside will be void. We can also change this to have this as a full part here from materials. The last thing I would like to show you here is, of course, this one. Is the easiest one to understand. You can just pick one part and delete. The next tool I would like to speak about is the auto offset. So during the skeleton workflow, many steps that Stuart was showing before have been performed automatically, and so the logic is first of all we cut the donor elements with the slice. We create automatically the sections and the beams with the 1D element discretization, and we assign the section to the beams, but and also the offset. So we compute the offset that is needed to be assigned to the C-beam to make the section to be in the right position respect to the midline. And so here we have an example, and here you can see if I open the section in Section Manager, how it looks like. Here you can see, especially please focus on the shear center position that is here, and this is important because the offset will be referenced to that position. Then in this case, you can see that I'm not happy with this gap here. I would like to close, so I can open Section Manager and close it. So this will cause a recomputation of the properties, especially for the shear center. In this case, as we are closing something, the gap between the two positions here and here could be, well, significant. In fact, when I escape the tool now, the offset that was assigned to the C-beam is not correct anymore. So auto offset will help us with that, and automatically, I will show you in 1 second the demo. It will reposition in the section and reassign to the C-beam the right. On the same model here, let me open in Section Manager that specific section. Okay. You can see the position of the shear center and the gap. This is one of the benefits of Section Manager using a sketcher. It will be super easy to close the gap. Now I escape, and then you can see here I have a kind of flying section. And before, to fix this one, well, we have to go to 1D probably and reassign manually the offset. But now in the skeleton ribbon, we can go to offset, just pick the member and say go, and then you can see that automatically it will recompute the offset and reassign properly the values to the C-beam.
So in 2025, there's a new option for the global, local, and order box, and it essentially allows you to create 2D faces on what would be the voxel elements. So there were requests coming in from the field that to run the topology more efficiently, more quickly, they just wanted an option to run it on 2D mesh as opposed to the 3D voxels. So now, yeah, there's an option that skins the face of every single face, not just external, but also internal as well. And everything is nodally equivalenced. We set up the DTPL, the P shell. I think the thickness is set to 1 by default. And all you got to do is assign a material and you're essentially run ready, or set up the responses, objectives, constraints. So it's another option there to run topology. A couple of other things. So in exoskeleton, we added the exclude function so that we guarantee that a 1D exoskeleton element is not passing through an excluded part or body, which is important for obviously load path definition. You can't have a load path running through something. So we've added that. And then the bottom option here is for order box, in that in 2024, we weren't deleting, if you use hardpoints, we weren't deleting the rest of the structure. Typically, you need to go through that manually in 2024. But now in 2025, we actually go through and remove the rest of the elements. We retain the hard points, obviously, for the load case boundary condition definition. And yeah, you've essentially got a run-ready topology optimization model in a very short period of time. Okay, a couple of other minor options. We've added the new create new include operation there within the options. That's for global, local, adhesive, and the exoskeleton workflows. So this organizes all your design space, the P shell or P solid, the DTPL, and everything else related to what we're creating, and puts in a new include. The last one down here is that we've added more fidelity to the input for creating a topology model, and that we now can pick morphing volumes, parts, and poly cages as well. So if you have a much more abstract or obscure shape that you wanted to pick, that's created through a poly cage, for example, through Inspire, then you can put that into the Hype Mesh, and we can actually create the design space directly on that poly cage.